Hello learners, I want us to look at a quick way in which we can write the equations to prepare gases and some selected acids. The first gas is oxygen. How do we prepare oxygen gas? We can prepare oxygen gas by having sodium peroxide reacting with water or by having the composition of hydrogen peroxide. So oxygen as a gas, we can prepare it by having 2 moles of sodium peroxide with 2 moles of water to form 4 moles of sodium hydroxide and 1 mole of oxygen gas. Or we can have 2 moles of hydrogen peroxide in the presence of manganese 4 oxide as a catalyst to form 2 moles of water and 1 mole of oxygen gas. We can also have thermal decomposition of some nitrate salts. We can have 2 moles of potassium nitrate being thermally decomposed to give us 2 moles of potassium nitrite and 1 mole of oxygen. We can also have 2 moles of lead 2 nitrate being thermally decomposed to give us 2 moles of lead oxide and 4 moles of nitrogen 4 oxide and oxygen gas. But learners, how do we separate nitrogen 4 oxide and oxygen gas? We pass the mixture of nitrogen 4 oxide and oxygen gas into a U-tube immersed in ice cold water. The ice cold water condenses nitrogen 4 oxide to form dinitrogen tetraoxide, which now becomes a pale yellow liquid, and oxygen is allowed to pass and gets collected. Now someone is wondering, what is dinitrogen tetraoxide? We have 2 moles of nitrogen 4 oxide in the presence of ice cold water is condensed to form dinitrogen tetraoxide, which is a pale yellow liquid. That is about oxygen. For the remaining gases, I will be writing the equations only. So be very keen. It is normally important that you understand and you master all the equations as a serious chemist. Gas number 2, we have hydrogen. We need zinc, metal, 2 moles of dilute hydrochloric acid to form zinc chloride and hydrogen gas. The catalyst here is copper 2 sulfate. We cannot use nitric 5 acid here because when nitric 5 acid is used, the hydrogen gas formed is going to be oxidized to form water because nitric 5 acid is a stronger oxidizing agent. Another gas here is hydrogen chloride gas. We need rock salt, which is sodium chloride, reacting with concentrated sulfuric 6 acid, which is less volatile. We form sodium hydrogen sulfate, but not sodium sulfate. Reason is sodium sulfate will require high temperatures, which cannot be provided in the laboratory situation. We are using conc sulfuric 6 acid because it is a less volatile acid. Number 4, we have carbon 2 oxide. We can prepare carbon 2 oxide by having dehydration of either ethane dioic acid or methanoic acid, HCOO, COOH. So we're going to have H, OH being the elements of water getting removed by conc sulfuric 6 acid. So I'm going to have this, I'm going to have this, I'm going to have this. HOH will give us water there. Then the COO will give us carbon 4 oxide. Then we are going to have CO as carbon 2. Now to separate the carbon 2 oxide from carbon 4 oxide, we pass the mixture of gases through either concentrated sodium hydroxide or potassium hydroxide, and therefore carbon 4 oxide will be absorbed, leaving carbon 2 oxide. We can also use methanoic acid. This is ethanedioic acid. We can also use methanoic acid. Again, we have carbon 2, then we have water. The process of removing the elements of water from a compound is what we call dehydration. What about when preparing carbon 4 oxide gas? When preparing carbon 4 oxide gas, we need the marble chips. The marble chips is what we call calcium carbonate. We need 2 moles of HCl to form calcium chloride, carbon 4 oxide, and water. The ionic equation here now becomes calcium carbonate, 2 moles of hydrogen ions, 1 mole of calcium ions, and carbon 4 oxide, and 1 mole of water. We cannot use sulfuric 6 acid here because we are going to form calcium sulfate, which is insoluble, and we will form a coat or a layer that prevents further reaction. Nitrogen 1 oxide is prepared in the laboratory by thermally decomposing ammonium nitrate. Then we form nitrogen 1 oxide and 2 moles of water. If we want to prepare nitrogen 2 oxide, we need copper tannins, 3 moles of copper tannins, 8 moles of dilute nitric 5 acid. We form 3 moles of copper 2 nitrate solution with 2 moles of nitrogen 2 oxide and 4 moles of water. This is dilute nitric 5 acid, or you can call it 50% nitric 5 acid. If you want to prepare nitrogen 4 oxide, we need 1 mole of copper, 4 moles of concentrated sulfuric 6 acid. Then we form 1 mole of copper 2 nitrate, and we have 2 moles of nitrogen 4 oxide, and we basically have 2 moles of water. If you want to prepare nitrogen gas, we need 1 mole of sodium nitrite. We need 1 mole of sodium nitrite. Then we need ammonium chloride. Then we form nitrogen gas. We also form sodium chloride, and we also form 2 moles of water. If you want to prepare ammonia gas, then we need the following: 2 moles of ammonium chloride, 1 mole of calcium hydroxide. We form 1 mole of calcium chloride. We form 2 moles of ammonia gas, and we form 2 moles of water. Last but not least, if you want to prepare nitric 5 acid in the laboratory, we need potassium nitrate, and we need concentrated sulfuric 6 acid, and we form potassium hydrogen sulfate and nitric 5 acid. It is normally in form of fumes because we have some heat here, which will sometimes decompose some of the nitric 5 acid fumes. When some of the nitric 5 acid fumes are decomposed, this is actually reversible. We're going to form 4 moles of nitrogen 4 oxide, 2 moles of water, and 1 mole of oxygen gas. And that is why when preparing this acid, you normally see some brown fumes, which are as a result of nitrogen 4 oxide gas. Thank you for listening to me and for listening to chemistry of gases, how we prepare them in the laboratory. Before I finish, I can't forget about a green yellow gas. which is chlorine. We can prepare chlorine in the laboratory by having 2 moles. By having 2 moles of potassium manganate 7, 16 moles of concentrated sulfuric acid to form 2 moles of potassium chloride, to form 2 moles of manganese 2 chloride, to form 8 moles of water, to form 5 moles of chlorine gas. We can also, here we don't need any heat, because potassium manganate 7 is a stronger oxidizing agent. We can also have lead 4 oxide with 4 moles of conc hydrochloric acid to form solid lead 2 oxide. To form, we also have chlorine gas, and we have 2 moles of water. Here we must have heat, because lead 4 oxide is a mild oxidizing agent. We can also have manganese 4 oxide. Then we have 4 moles of concentrated sulfuric acid. We form manganese 2 chloride. We also form 2 moles of water. We also form 2 moles of water, and again 1 mole of chlorine gas. And that is the end of the chemistry of gases, nitric 5 acid. May God bless you. See you again in subsequent lessons. Bye-bye.